Good morning and afternoon, everyone. My name is Nick Narzinski with P3 Technologies, and today we're going to take a look at advanced geometry selections within Fusion 360. So we've got a half hour scheduled for this, and we've got a pretty full agenda, so I think we'll take the entire 30 minutes, but I'll give contact information at the end if you guys have any questions or need to reach out to us. So we're going to take a look at operation options for containment. So I've built a chart that shows which toolpaths work similarly with each other. And then we're going to take a look at how tool containment works. And I'm also going to show just a preview of how AnyCAD functions within Fusion 360. Then we'll take a look at 3 techniques with examples. So there are just 3 good examples I've pulled from customer support issues that they've had in the past and how to get around those. And then if we have time, I'm going to show some quick tips for toolpath selection. So before we jump into it, I do want to mention our Fusion Velocity program D3 Technologies has put together. So this is a full up and running program to get you up to speed. So we have about 13 full day classes that you can attend remotely or in class, and I'll show that in just a second. Then it also includes live instructor-led classes. So those are hands-on exercises and everything. Then we got tech support that you can call in, chat in, or email into us. And then we also included Fusion hours. Once a month, we'll have just I think a half day where you can call in with any questions you have, or maybe you just want to talk about workflows or something like that. So the training side of it, so we call this CAD Live. We got instructor-led, but it's also virtual. So you can see here in this image, we've got an instructor which is training from a different office location. We have attendees here, so you'll be able to see the instructor, see his screen, and you'll also be working on a virtual machine, and the instructor can remote in and help you out with exercises. So it's very interactive and a great way to communicate and learn from just about there. So this also works even if you're working from your home. As long as you have two monitors, a good internet connection, a webcam, and a headset, we are able to give you a remote desktop that you can, again, run the software through the exercises. The instructor can see your screen. You can see the instructor and his screen. So awesome technology we put together to make this all work. And all that is for $495. I think it starts at $495. So you guys can check that out at teamd3.com/solutions/fusion-360. All right. So operation options for containment. So I've put together this chart of the 3D 3D toolpaths within Fusion 360. And so you can see the ones in red work similarly. So you can see what we have as far as options here. Don't get too deep into this. I'm just wanting to show basically that these 2 roughing operations, adaptive clearing, pocket, work very similar together. And these ones in yellow, contour, parallel, scallop, pencil, radial, and spiral all have very similar options as far as how to contain that toolpath. There is one on here that I did not add, which is flow, and I'll show that today as well. So starting with tool containment, almost all these 3D operations have the option to say tool inside the boundary, tool center on the boundary, or tool outside the boundary. So if I take a step back, the big difference between the 3D toolpaths and 2D toolpaths, if you're not aware, is 2D, you're selecting geometry and telling it where to cut. So you're picking pockets, you're picking edges. You're telling it with geometry features exactly where to cut, versus the 3D toolpaths work off of surfaces for the most part. So you're picking boundaries from the top view down. So if you're at the spindle Z-axis looking down at your part, you're picking boundaries to contain that toolpath. And then there's different options inside those toolpaths to either avoid or machine different features within inside of that boundary. So when you say tool inside boundary, if we're looking at just a square, you're saying that the tangent of that tool can't go beyond the perimeter of that boundary. Tool center on boundary says the tool center can go out to that boundary but not past it. And then tool outside boundary means the tangent of the tool can go all the way to the outside edge of that boundary. And if we look at that from an elevation view, you can see the tool, when it comes down, it hits the edge, center on the edge. Now here's where things can get tricky, is when you say tool outside boundary, that tangent of the tool if you're not controlling how deep the tool can cut with your bottom height, that can go all the way down the side of the part, which you may or may not want. So we're going to take a look at ways to get around that. So actually, I'm going to show that example real quick before I jump into this. So looking at that cube, and this is where I wanted to show how AnyCAD works. So right now it's still in preview with inside Fusion. Let's do Fusion first just so I can show that. So if you go up to your name, down to Preferences, and go to the preview, there is an AnyCAD checkbox. So this works right now for Inventor and SolidWorks only. I have a feeling that that'll be expanded to other file types in the future. But just to show it with Inventor, here I have just a simple, that same cube that I was just showing in the 2D drawing. This is an Inventor part file. We're working in Inventor. So the way that this works is I'm going to do a save with it, save as. And I've got some search groups here. Really what I'm looking for is once you have AnyCAD installed, within your PC, you'll see there is a new Fusion 360 folder. So I've got a quick link to it here, this Fusion 360. So you can see here it's now inside of Fusion 360 D3 Tech. And so within inside of this hub that I have created, I've got a folder called Release for Manufacturing. So I'm going to go to that folder and just save the cube to that location. Ooh, yeah, I have that file open. Let me just call it something else. Okay, so that file has now been saved in that location. So now when I jump over to Fusion, I'm just going to start a new design. And I'm going to save that into my that's where I want to save it. So I'm going to call that cube 2. We'll save that there. And so now I'm just going to go to my data panel and find that same project, Release for Manufacturing. So you can see that this stays in sync with that same location that we just saved it out of Inventor. So here you can see the cube 2 that we just saved as a IPT file. I'm just going to right click here, insert into my current design. Once that's brought in, we will see that that is now linked to that Inventor file. So this will also work for SolidWorks files. If you get those from customers or maybe you're using Fusion in conjunction with SolidWorks, you can have your design team save those to the location, access it within Fusion, and then start programming it. Any design changes that happen to that part are then going to be updated with inside Fusion and your CAM toolpaths. So let's just create a quick setup here. And I'm just going to throw on a 3D pocket operation. Let's grab a flat now. ½ inch. So geometry, I'm going to leave this to bounding box, which is going to basically be the box or the top segment. And if I say tool inside boundary and say OK, you can see the tool stays inside that boundary. Let's do the same thing with parallel. Same tool. This time I'll say silhouette, which is basically the same as a bounding box because looking down, it is a box as far as the shape goes. Tool inside boundary again. We see that the tool stays within inside the containment. I'm just going to duplicate those. Let's do it twice. So now I've got 3 of each. I'm going to right click, go to compare and edit. If you guys don't use this, it's a pretty awesome tool. I can search for containment, and here I can see all the parameters for that operation as far as boundaries go. So inside, we're going to do 1 to center, 1 to outside. Same thing with parallel, 1 inside, 1 center, and 1 outside. I'm going to regenerate those toolpaths now that I've made those changes. And now you can see the pocket on the inside, the pocket on the center, the pocket on the outside. Now, when I go to parallel, we've got inside, center, and see what happens? That toolpath goes down and drags the side of that part. So there's a couple ways around that. One, you can come into that operation and just adjust the heights and move it up to a certain level that it'll stop at. It's still going to come down to that level, as you can see. The other one, and this is a tip I learned from one of Rob Lockwood's webinars, is you can go into the additional offset and use the tolerance from the passes tab. So right now it's set to 4/10. And if I go back there and hold down the shift key and hover over that, you can see the parameter name for that is the word tolerance, all lowercase. So I'm going to reuse that. I'm going to say negative tolerance times 1.1. Hit enter. And that toolpath, so let me show what that calculated to. It calculated to negative 44,044. And when I highlight that, so now that toolpath no longer drags on the outside. So there's a long explained reason for that as far as how the toolpaths are calculated. I'm not going to go into that today, but that's just a good tip. And if you ever have that issue where it drags on the side, you can enter that in there, and that'll keep it from going any further. All right. Oh, and so with AnyCAD, if I come back to Inventor, just for instance, just so you guys can see this, let's just throw a direct edit on here and move that face a certain distance, say okay, save that file. If I jump back to Fusion now, it might take a second here. So let me go to the right folder. Save that. All right, here it is. Component is out of date. Update to the latest version using the get latest in the model environment. So go to model, right click, get latest. Give it a second to update the data. That now updates to the changes we made with inside of Inventor or SolidWorks. Go back to the CAM environment, regenerate my toolpaths, and those are now going to update to those new model changes. So pretty awesome functionality they've added to Fusion. So check that out if you guys have any other CAD platforms that you're working with within Fusion or with Fusion. All right, back to the PowerPoint. The first example I wanted to go through was a void surface with boundary selection. So we're going to use the avoid touch surface in conjunction with selecting a certain boundary. So let's go back to Fusion, open this file up. All right, so I already have a setup in here. And so what I'm wanting to do is add finishing passes on the slanted face. So I'm going to use a ball mill and just run it up and down with step over passes all the way across. So I'm going to start doing that with parallel. There's a better way to do this now, but I'm going to start with this because it's a good example on how to use a void touch surface. So let's just grab half-inch ball mill. I'm going to go down and change this to selection. I'm going to pick an edge. That's part of the boundary I want. Once that happens, it's going to kind of automatically pick tangent edges to try and come up with a closed boundary. If you need to edit that, I'm going to pick that profile again. That puts it into edit mode. So now you can see these selection tools. The way this works is you just re-guide the toolpath. So I selected that edge first, it's blue. It looks good all the way around up until right here. It goes where I don't want it to. So I'm going to hover my mouse over here, click there. Then I'm going to hover my mouse right here. I can see that it's going the right direction, so I click there. Then I'm going to come over here. That's not right. I'm going to click there and click there. So anywhere it guides off or veers off where you don't want, you just need to hover over it until you get what you want. Select the edge, and then once you're finished, click the plus sign. So again, we're not picking actual edges, we're picking boundaries. We're just using edges to create that boundary. So looking down from the top, that's where it's going to contain the toolpath down to any surface it sees below that boundary looking down. So if I was to, and the parallel passes always go along X within your setup. So I'm going to say 90 degrees to that right off the bat. We'll do a 40 thou step over, and let's just say okay. All right, so that doesn't look too bad. It does look like it comes up and wraps that top surface. But the other issue I see if I go to simulate this is when we get down to the bottom here, we aren't machining that full surface because we said tool center on boundary as far as our geometry containment. So I'm going to change that to tool outside boundary and say okay. The issue there is now, again, it wraps the entire outside surface. It also wraps the sidewalls, the top. So there's a lot of stuff that is machined now that we did not want. But we needed that in order to get the ball mill to come all the way down that face. So what I do, and this is used commonly, is with conjunction of boundaries, is you come in and tell it what to avoid. So I'm going to check this avoid touch surface. Now I can come in here and select all those adjacent edges, or surfaces rather, that it was wrapping to. If you pick something incorrect, oh, I didn't want the body. So again, I'm just picking all those surfaces. Okay, so now we say okay. And that looks a lot better. Now if we simulate that, our tool still comes down and gets the entire surface. So that's one method to do this. There is a better method now that they've added flow to the software. So if I come up here to multi-axis, there's a flow toolpath. This works in multi-axis as well as 3-axis. So same tool, all I'm going to do this time, this one works off of actual surfaces. So I'm just going to pick the surface. If you click the arrow, you can change which direction it's going to cut. And this one, you just decide how many step overs you want spread across that surface. So if I was to do 50 step overs, I probably should have tested this first. Let's try 2. Oh, you know what? I did have issues with this after the last update. That should work. It should get a very similar. You just decide how many step overs that are divided across that surface. That I believe is a known issue as far as that goes. So the next thing that I wanted to show was using model surfaces to guide that toolpath as opposed to avoid touch surface. So this is a common mistake I see is people use model surfaces here to try and tell it what to machine. In reality, that's to add surfaces to the model from the setup. So jumping back over here, let's open up that file. Okay. You can see my Z and my X. So I'm going to do parallel passes across the surface. Pick this 1/4-inch ball mill. For geometry, I'm going to pick that bottom boundary. That's exactly what I wanted. It goes up to the tangents of the fillet there. And we want to go along X as far as our passes go. Let's do 20 step over. We've got tools centered on that boundary. Let's go ahead and say OK. So a couple things, quite a few things actually. One, you can see we're coming up and wrapping the sidewalls, and I want it to just stop at that tangent where the boundary is. Two, it's trying to wrap down inside the holes and this U shape with inside of there. I could select that circle and that horseshoe looking shape as part of a boundary, and it should machine between the boundaries, but I just want the toolpath to go across it like it doesn't exist. And then the third issue is all these rapids that we have here on the excuse me, on this end. So let's go back in there and see what we can do about this. The first one's pretty easy as far as it touching the sidewalls. I'm just going to come in there and do the same thing we just did and pick those side faces and avoid those. So now we still have some rapids and very large lead-ins, it looks like, to come down and meet that up. On this side, it's fine. I can just do a simple transition. On this side, it can't do that transition without colliding with the fillet there. So what it does instead is it comes all the way up and does a transition and rapid. And then comes back down. So the way to avoid that, we can go to the linking tab. You could mess around with these parameters. I would probably just go with straight line here as far as the transition type. And now it should just go straight over as opposed to rapiding all the way up. So then the third issue is what I'm going to use the surfaces for, and that is to avoid these features. And the way to do that is to jump back into the model. The model, but the patch environment. So I'm just going to create some surface patches over those features because I still want to be able to machine them in the future with different strategy, drilling and some type of strategy on this horseshoe, but I want to avoid them as far as this parallel toolpath goes. So I'm just going to come here to create. We're going to use a patch. And so it's looking for edges. I want this to be a new body. So I'm just going to pick. I need to create a closed loop here of all these edges. Once you've got a closed loop, it gives you a good preview of that patch and say, okay, I'm going to repeat that command, do the same thing for that hole. So those are patched surfaces over those features. Now when I jump back into the environment, to the model, and we did the geometry, and this is what model is meant for, is to include. So I'm just going to add those two surfaces and say okay, and now that toolpath should run right across it like it's part of the model, like it doesn't exist. So hopefully that's a good trick to help you guys. So those are good for things that are in a flat plane. What if you have something like this, or maybe some type of curved surface that you can't really just patch it very easily? That's where the next, let's switch back to PowerPoint. That's where my next example comes in. So I've got two ways to get around this. So if you want to machine maybe just that slanted or that chamfered surface, like those holes don't exist without trying to go into those holes, that's what we're looking for. So I'm going to use, I got two methods. One is creating basically a copy and paste of the model and have two models, one with the holes and without. And the other method being using protecting toolpaths and coming back and machining those. So I'm going to do the latter first, switch to the cam environment. Let's do let's throw a flow toolpath on there. I think this will work. So select them all, they're all going the wrong direction. I didn't change each one individually because there's a way to change all of them on the passes tab. So instead of along U, we'll go along V. That is what I was looking for. Let's do 20 step overs and pick a tool. We'll get a 1/2 inch. Okay, so it's machining the right surface. However, it's seeing all those holes and doing rapids over it. Again, I just want to go over them like they don't exist. So the way I would probably do this is to jump back into the model. And the first method I'm going to do is just copy and paste. So I'm just going to expand the body, right click, copy that, right click, paste it. And I'm not going to move it around because I want it to lay exactly in the same positioning as the first one. So by doing that, I now have 2 of the same exact body. And for simplicity, I'm just going to rename these. I'll say with holes and no holes. So I'm going to hide with holes, and I'm going to delete all of the ones with no holes. So if you aren't aware of direct editing, it's very easy to do within Fusion. You just select the features you're wanting to get rid of and hit the delete key. And it heals the model, and now you no longer see any of those cutouts. So now if I jump over to the CAM environment, let me just check my setup here, that looks good. Jump back into the flow toolpath. Let's just make sure our setup is the way we want it here though, because now we have 2 bodies in there. It should be the original because that was all that was there when it was created. But just make sure when you guys are doing your setup with this that you pick the finished product as your model here. Because if you're going to come back and drill those out, you want to realize that those were there. If you tried to do something else, maybe a roughing operation, and you had both the models selected, it's not going to see those holes. It's going to stop at the first surface it sees, even if the visibility is turned off. So I want to check with holes as my model body. And then I'm going to come back down the flow, edit that, go to geometry, select model, and this time I'm going to add those new model surfaces to the toolpath calculation. Kind of similar to what we did last time, but this time we're actually using modeled surfaces. Oh, and I want to get rid of those. There we go. So that's one method. There is what I would consider an easier way. So that's using 2 different models. And then you can go back and switch, and now you can do your drilled operations on the other ones. The other method, let's just delete that. Come back to the model. And I'm just going to keep the one with the holes. We can delete the one with no holes now. And so what I would do here is I'm going to right click on my model and say capture design history. Now I'm going to come in here, hold down the control key on my keyboard to multi-select all of these holes again. Click the delete key on my keyboard. Now we have parametric, a way to get back to keeping history of what was just done, I guess is the best way to put that. So by doing it this way, I can now go into the model environment, create that same toolpath, So flow, let's pick that same tool. Pick all my surfaces. Let's do 20 passes along V and say OK. So we get a nice clean tool path. The difference being, now we can go back to, actually first, before I switch back, let's right click on that tool path and protect it. You get this little lock key. So that's basically locking that tool path into the geometry as it sits. Any changes you make to the model, you're not going to get those red X's next to it because it's locking that tool path in. So now if I switch back to the model environment, I can simply drag my end of part marker over. My holes reappear. I can now switch back to the CAM environment and continue programming as the original model. And that tool path is no longer invalid. It keeps it locked at how it was when we created it. So hopefully that's a good example that can help you guys as well. That's how we do on time. We're right at 11:30. All right. So the last thing was my quick tips that I had. And to show those, I've got a flat mill part here. And I just wanted to show, so I've got a setup created. I've got a flat mill tool that I created. And I want to show how you can utilize notes within templates. Let's activate this setup. I'm going to right click. If you guys aren't familiar with this, definitely look into it, creating templates. So I'm just going to go to slot mill 2. This is one I've already created. Let's say I haven't used it in a while and I forget exactly what I needed to do to make that toolpath work. I created a note on it. So if I right click on that toolpath and go to edit notes, I can see here, select bottom edge as of the slot as the geometry selection and select the top edge of the slot as the top height. So all I got to do now is go in there and edit that toolpath, pick those edges for the bottom, and then for the top, it's looking for a top reference. So I pick that and say OK. And now I've got my slot mill operation. So that was one of the tips. And then the other one was derived toolpaths. So if you guys aren't sure, especially when you're getting started, of which toolpaths you want to utilize, excuse me. Let's go back to the model here and drag it to the end. Go to the CAM workspace, and you can, that's probably not a good example to drive from there, but if I had like contour, for example, and contour would actually be a better example of when you would use two models because it's working off of the model itself instead of surfaces like the flow toolpath. So if I did those two selections, say OK, I get that toolpath. So again, that this create derived operation just allows you to drop the same selections into multiple toolpaths. So if I do that one, maybe ramp, say OK, create derived 3D milling, and let's just do maybe a parallel. It's probably not going to look good, but just to give you an example, when you get your selections made, you can just go in there, derive those toolpaths into different types, and then go back and look at them and try and decide which one gives you the best results. So hopefully those are some good tips for you guys. You can reach out to us at 877-731-7171 if you guys need to contact us. My email address, if you have any questions on this webinar, let me just jump back to the beginning, is nick.narzinski@teamd3.com. So I appreciate you guys paying attention today, and I look forward to next time.